Alright, this lesson is 5.2. We're going to be dealing with central angles and arcs. We need some definitions. A central angle is an angle whose vertex lies at the center of the circle. Pretend that that's the center of the circle. That one is a bad drawing. But that would be the central angle, and they always call it theta. The length of an arc is simply the length of this arc. If you were looking at a pizza, it would be the crust. Like, how long is it? If you were to flatten it out flat and measure it with a ruler. The length of any circular arc S is equal to the product of the measure of the radius of the circle R and the radian measure, that's very important, of the central angle theta that it subtends. Subtends just means cut off. The formula is S equals R theta, where S is the arc length, R is the radius, and theta is the central angle. So S is the length of the arc, R is the radius, theta is the central angle. And we're going to use that formula, and theta has to be in radians. So if it's in degrees, like this one for example, it says find the length of an arc that subtends a central angle of 42 degrees in a circle of radius 8. Well, S equals R theta. The radius is 8 times theta. Well, theta is 42 degrees. I don't want degrees, so I have to change it to radians by multiplying by pi over 180. So you would do 42 divided by 180, and you'd get 7 pi over 30. And you'd multiply them together, and 8 times 7 is 56 pi over 30. Or if you wanted an actual length, if it says to leave it in terms of pi, you're done. That's the answer, and that would be centimeters. If it wants a decimal, you would just type in 56 pi over 30. 5.864. And that's centimeters. And you'll know if it says in terms of pi or if it says round it to 2 decimal places. It says for a circle of radius 7, find the arc length subtended by a central angle of 30 degrees. So you can pause me and try this one because it's very similar. And then come back. Welcome back. S equals 7 times 30. Well, I have to convert it to radians. So that's pi over 6. So S would be 7 pi over 6, or 3.665. And that is feet. Now it says given the measure of an arc, so they're giving us S. Find the degree measure, this is going to be tricky, to the nearest tenth, so that's 1 decimal place, of the central angle it subtends in a circle of radius 10. So they're giving us S, they're giving us R, and they want us to find theta. So we would solve for theta. So theta is 0.7, but that is in radians, because the theta in the formula is always in radians. So how do you change it to degrees? Well, I do 0.7 times 180 over pi, and this is one where the pi doesn't cancel, so I type it in. 0.7 times 180 over pi. 40.1. It says 1 decimal place. I like 3.107, and that is degrees. For degrees, you can just go to the nearest tenth because they're so small. 1 decimal place is fine. And again, if you want to pause me and try this one, 21 equals 10 theta. So theta would be 2.1, or 2.1 times 180 over pi, 5.7 degrees. I think I typed that in wrong. Sure did. 2.1, not 0.1, times 180 over pi. About 120.3. That's a little bit better. or 120.3 degrees, because you have to do 2.1 times 180 over pi to get it in degrees. The area of a sector formula, it says if theta is the measure of the central angle expressed in radians and r is the measure of the radius of the circle, then the area of the sector is 1/2 r squared theta, where theta is in radians. And what a sector is, if I sketch that for you really fast, I want to draw a circle. That's an interesting circle. Here's my circle, and this is my center. The area of the sector is just the piece of pie. It's the area of the slice. So it's close, it's going to be close to the area of the triangle. That's why you think about the area of a triangle is 1/2 base times height. This is 1/2 r squared theta. So it says a sector has arc length of 16 centimeters, so S is 16, and a central angle measuring 0.95 radians. Find the radius of the circle and the area of the sector. So I've got two pieces. First thing, I want to find the radius. So S equals r theta. I have a formula relating S, r, and theta, so I fill it in. R 0.95. So I solve for r. It was already in radians, so I didn't have to convert it. So 16 divided by 0.95. Did I just do why can't I type anything? Darn it. 16.842. Let's go ahead and carry all those decimals. And then find the area of the sector, so 1/2 r squared theta. So 1/2 r squared theta. And we just type all that in. So 1/2 times r, well, it's still in my calculator, I'm just going to go control answer, squared times theta. 134.737. Unless I messed up, which is possible. And that's its area, so it's centimeters squared. Did I mess up? I shouldn't have. Let me make sure I didn't type anything in my calculator wrong. No, that's right. And did you notice that when I pulled in the second answer right here, it pulled the entire decimal? So I'm not rounding from one step to the next. Had I just did 0.5 times 16.84 squared times 0.95, I'm going to get something close, but if my decimals are going to be off. Now, which one's more accurate? Well, obviously the one where I keep all my decimals. So as a rule, from here on out, if you use an answer, just like we stored K in the last chapter, if you use an answer from one step to the next, make sure you keep the whole decimal, either by storing it or by doing second answer. And then it says find the area of a sector with a central angle, so I want to find the area of a sector with a central angle of 160 degrees and a radius of 5.4. Now, my angle needs to be in radians. It is not right now, so I times by pi over 180, and that's 16 pi over 18, or 8 pi over 9. So A equals 1/2 r times squared times theta. So 1/2 times 5.4 squared times 8 pi over 9. 40.715. And that is centimeters squared. And that is all. So go check yourself off and get a piece of candy.